Managing changes and supply disruptions is a critical responsibility within manufacturing planning and control because supply chains operate in environments characterized by uncertainty and constant change. Demand fluctuations, supplier performance issues, transportation delays, equipment failures, labor shortages, engineering changes, and market volatility can all disrupt carefully developed plans. Organizations must respond quickly while maintaining alignment with customer requirements and business objectives. Effective disruption management requires visibility across planning systems, clear communication channels, and disciplined decision-making processes. Planners must continuously monitor both internal operations and external supply networks to identify emerging risks and implement corrective actions before disruptions significantly affect production schedules, inventory availability, customer service, or financial performance. One of the primary tools for responding to disruptions is the ability to reprioritize internal production orders and supplier orders within established planning rules and time fences. Time fences provide schedule stability by restricting changes during certain periods, but organizations may still need to make controlled adjustments when significant supply or demand changes occur. Priority decisions often involve evaluating customer commitments, strategic importance, profitability, contractual obligations, and operational constraints. Internal production schedules may be resequenced, supplier deliveries expedited, or inventory allocations redirected to support critical requirements. Effective reprioritization balances responsiveness with schedule stability, ensuring that necessary changes are implemented without creating excessive disruption throughout the manufacturing and supply chain network. Supply and demand variability can occur in both timing and quantity, creating unique planning challenges. Timing variability occurs when demand or supply arrives earlier or later than expected, while quantity variability occurs when actual volumes differ from forecasts or commitments. These variations may result from forecast inaccuracies, customer behavior changes, supplier reliability issues, transportation disruptions, production inefficiencies, or market conditions. Organizations must understand the sources and patterns of variability to develop effective mitigation strategies. Because timing and quantity variability can affect inventory levels, production schedules, resource utilization, and customer service, planners must continuously monitor performance and adjust plans accordingly. Effective management of variability improves supply chain resilience and operational reliability. Planning parameters must be reviewed and adjusted regularly to ensure planning systems reflect current business conditions and strategic objectives. Key parameters include lead times, lot sizes, safety stock levels, replenishment quantities, cycle times, sourcing strategies, and order policies. As products progress through different life cycle stages, planning assumptions may need to change significantly. For example, growing products may require increased safety stocks and shorter replenishment cycles, while mature or declining products may require inventory reductions and revised ordering policies. Changes in supplier performance, market demand, capacity availability, and operational strategy also influence planning parameters. Maintaining accurate planning settings improves planning effectiveness and supports better decision-making throughout the organization. Analytics play an increasingly important role in evaluating trade-offs associated with changes to internal and external supply plans. Advanced planning systems, business intelligence tools, predictive analytics, and scenario modeling capabilities allow organizations to assess the consequences of alternative actions before implementation. Planners can compare options such as expediting shipments, increasing inventory levels, reallocating capacity, changing suppliers, modifying production schedules, or adjusting customer commitments. Each alternative involves trade-offs among cost, service, risk, capacity utilization, and inventory investment. Data-driven analysis enables organizations to make informed decisions that balance competing objectives while minimizing disruption. The ability to evaluate multiple scenarios quickly enhances responsiveness and improves the quality of planning decisions. Maintaining resilience requires continuous monitoring of internal and external redundancies and strategic buffers. Redundancies may include backup suppliers, alternative production facilities, secondary transportation options, cross-trained employees, and additional inventory reserves. Strategic buffers provide protection against uncertainty by absorbing variability and supporting continuity during disruptions. Organizations must regularly evaluate the adequacy, location, and effectiveness of these safeguards while balancing resilience against cost considerations. Excessive buffers can increase operating expenses and inventory investment, while insufficient buffers increase risk exposure. Effective monitoring ensures that contingency resources remain available when needed and continue supporting organizational objectives. By combining proactive planning, flexible resources, analytics, and disciplined monitoring, organizations can successfully navigate supply disruptions and maintain reliable operations.